You ever been there? You're hours into debugging and you finally find the problem. You broke something you wrote weeks ago. Ugh. Well, today we're diving into a practice that tries to make that whole nightmare a thing of the past. It's called test-driven development, or TDD for short. And yeah, it kind of flips the usual way of doing things on its head, but it might just be the key to writing better, safer code. So let's get into it.
Okay, let's just get right to the weirdest part. The absolute core idea of TDD is that you write your tests before you write a single line of production code. And if you're anything like me when I first heard that, you're probably thinking, wait, hold on, what? How on earth can you test something that doesn't even exist yet? It just sounds completely impossible, right?
And you are definitely not alone at thinking that. It feels totally backward. But what if I told you that this whole strange idea is the secret to writing cleaner, more reliable code with way less stress? There's a really powerful logic to this madness, and it all centers around a simple, repeatable little rhythm.
So at the very heart of TDD is this little three-step process. It's called the Red-Green-Refactor cycle. You can think of it like a disciplined little dance you do for every single piece of functionality you add, no matter how tiny.
And this is where the magic really happens. TDD completely changes how you think about testing. Instead of tests being this big, scary thing you do at the very end, where you're just hoping you didn't break anything, they become your guide. They're like a little roadmap, telling you exactly what piece of code you need to write next.
The whole cycle is just these 3 steps. First, you go red. That means you write a test, and you guessed it, you watch it fail. Then you go green. You write just enough code to make that one test pass. And finally, you refactor. You clean everything up and make the code better, all while making sure your tests stay green. So let's break down each of those.
First up, the red phase. You write one small, super focused test for one specific thing you want your code to do. And here's the most important part. You run it, and it absolutely has to fail. A failing test actually proves 2 really important things. 1, that your test works, and 2, that you haven't written the feature yet. You've basically just defined what you need to build.
Okay, now for the green phase. Your one and only job right now is to make that red test turn green. And the key here is discipline. You have to write the absolute minimum amount of code to make it pass. Nothing extra. Don't try to guess what you might need later. This is what keeps your code so clean and focused. And finally, we refactor. Now that you have a passing test acting as a safety net, you can make the code better. You can clean it up, maybe make it run a little faster, or just give a variable a better name. And how do you know you didn't just break something? Easy. You just run your tests again. As long as everything is still green, you can clean up your code with total confidence.
All right, so that's the theory. It sounds pretty simple, right? But let's see how this actually works in the real world. We're going to build a super simple password validator function, and we'll use that red-green-refactor cycle for every single new rule we add.
Okay, so our very first requirement is pretty straightforward. The password has to be at least 8 characters long. Easy enough.
So we start in the red phase. We write our first test. It'll probably check that a password like short is invalid, but a password like long enough is valid. We run it, and, of course, it fails. Our function doesn't even exist yet. We're seeing a big red error, which is perfect. That's exactly what we wanted.
Now it's time to go green. We create our function, and we write the absolute simplest code we can think of just to check the password's length. Nothing else. We run the test again, and boom, it passes. We are green.
And now we refactor. I mean, the code is probably just one line, but maybe we can make a variable name a little more clear. We make a quick improvement, run the test one more time just to be safe. Still green? Awesome. First requirement is officially done. Time to move on.
Okay, let's make things a little more interesting. Our next rule, the password also has to contain at least 1 uppercase letter.
Right, so we start the cycle all over again. Back to red. We add a new test just for the uppercase rule. Now, when we run our entire test suite, something really cool happens. Our original test for length, it still passes. But our new test for the uppercase letter, it fails. This is amazing. It tells us exactly what we need to build next, and it confirms we didn't break anything that was already working.
So we go green. We jump back into our function, and we add just enough new logic to check for an uppercase letter. We run all the tests again, and what do you know? Both our original length test and our new uppercase test are passing. Everything is green. Our function now does everything we need it to do, and we have the tests to prove it.
Okay, so you get the process, right? You just repeat this tiny little loop over and over again, building your software one tiny proven step at a time. But You might be asking, why bother? Is all this really worth the effort? What's the actual payoff here?
Well, the single biggest benefit is confidence, pure and simple. As you write these tests, you're building this incredible safety net for your code. It gives you the freedom to make changes or add new features without that awful, nagging fear in the back of your mind. You know, the one that says, I hope I didn't just break something. If you did, the tests will tell you immediately.
And that safety net gives you a ton of other benefits. You catch bugs the second you create them, not weeks later. You stop over-engineering because you only ever write code to pass a specific test. And your tests themselves become a form of living documentation. Anyone can read them and know exactly what the code is supposed to do. Oh, and debugging gets way faster because you know the problem is in the last few lines you wrote.
And hey, this isn't just some abstract idea. It has a real, measurable impact. When teams really commit to TDD, some have reported a massive drop in the number of bugs that actually escape into the wild, sometimes as much as a 40% reduction. Think about that. That's a lot less time spent fixing things, and a lot more time building cool new stuff.
So let's kind of bring it all home. What starts out feeling like this weird, totally backward process, well, it pretty quickly turns into a powerful, forward-thinking tool for just building better software.
So if there's just one thing you take away from all this, let it be this. Test-driven development isn't really a testing technique, it's a design technique. It forces you to think about what you want to build first, and then it guides you there, one small, proven, confident step at a time.
You see, in the end, TDD is all about building that safety net that lets you change and grow your code over time without being afraid. It changes your whole mindset from, I really hope this works, to, I know this works. So, you have to ask yourself, could this disciplined, test-first approach be the secret to truly fearless coding? It's definitely something to think about. Thanks for tuning in.